this episode, we're going to make network booting feel simple and predictable because PXE can sound like a niche acronym until you realize it is just another way a computer chooses where to get its startup instructions. The reason this topic matters for the exam is that Linux often shows up in environments where machines are installed, repaired, or managed at scale, and PXE is one of the most common ways to do that without touching every device physically. Even if you never plan to build a network boot setup yourself, you still need to recognize what PXE is trying to do, what components must cooperate, and what kinds of failures appear when one piece is missing. The exam usually frames PXE as a concept that connects boot flow with networking basics, and it tests whether you can reason about dependencies rather than memorizing obscure details. By the end, you should be able to describe where PXE fits in the boot chain, what it needs to succeed, and how to interpret symptoms when it fails. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. PXE is short for Pre-Boot Execution Environment, PXE, and the name tells you the key idea. It happens before the operating system boots, in the pre-boot stage where the machine is still deciding how to start. In the normal boot story, firmware chooses a boot device like a disk, and then a bootloader loads the kernel, but PXE changes the source of those early boot files. Instead of reading boot instructions from local storage, the machine uses the network to obtain a boot program and the files needed to start a system. This is useful because it lets a central server provide the same boot image to many machines, which is great for installing Linux, running a recovery environment, or performing diagnostics. The machine doing the boot is often called a client, and the network services providing the boot files are typically running on a server. The important exam frame is that PXE does not replace the kernel and user space concepts you already learned. It just changes where the early pieces come from. You still end up loading a kernel and transitioning into a user space environment, but the early handoff includes the network as part of the chain. To place PXE in the boot flow timeline, imagine the machine powers on, firmware runs, and instead of choosing a disk, firmware chooses a network boot option. That decision usually relies on a network interface card that supports PXE, and many systems have this support built into firmware. Once network boot is selected, the machine needs a basic network identity so it can communicate, which means it must obtain an address and learn how to reach the boot server. The client then downloads a small network boot program that acts like a bootloader, and that program can download additional files such as a kernel and an early user space image. That early user space image is similar to what you learned previously as initial RAM disk, INIT or initial RAM file system, INIT or AMFS, because it can provide a temporary environment to continue the boot process. After that, the system may run an installer, load a live environment, or continue into a full operating system, depending on the design. For the exam, the biggest idea is that PXE inserts networking into the earliest stage of boot, so the failure modes are often about network reachability and boot file availability rather than about local disk corruption. When you can place it on the timeline, you can reason about what the machine is trying to do when it fails. Now let's keep it plain and focus on the minimum set of things that must work for PXE to succeed, because that is where exam questions usually live. First, the client must be physically connected to the network in a way that supports boot traffic, which means link and basic connectivity must exist. Second, the client must obtain network configuration, most importantly an address and information about where to find the boot server. Third, the client must be able to download the initial boot program and any follow-on boot files reliably. If any of those steps fails, the machine cannot proceed, and it will typically show a message indicating where it got stuck, such as failing to obtain an address or failing to download a file. The exam will not necessarily ask you to build the service, but it will often present a symptom and ask what category of problem is most likely. Your job is to identify which dependency failed based on the stage at which the client stopped. This is similar to reasoning about local boot, but the dependencies include network services rather than local storage. One of the most common PXE failure patterns is the client never getting a usable network configuration. which usually means it could not obtain an address or boot server information. In plain English, the client is standing on the network shouting, "Who am I and where do I go?" and nobody answers. This can happen if the network is not connected, if the network configuration service is unavailable, or if the client is on the wrong network segment that does not provide boot support. The exam sometimes hints at this by describing repeated attempts to request an address, timeouts, or a message that indicates it could not contact a server. The key is that this failure happens very early, before any boot files are downloaded, so you should not jump to conclusions about missing kernels or corrupted images. If a client cannot even get an identity, it cannot reach the next step, and that points to basic network boot readiness rather than to operating system content. This is also why PXE tends to be sensitive to network design, because the pre-boot environment is minimal and does not have the same resilience and tools as a full operating system. If you remember that, you will interpret early failures as connectivity and configuration problems first. Another common failure pattern is when the client gets an address but cannot download the boot program or the follow-on files. In that case, the network identity part worked, but the file retrieval part did not, which narrows the suspect list significantly. In plain language, the client knows who it is and where it is supposed to go, but it cannot reach the place where the boot files live or cannot retrieve them successfully. This can happen if the boot server is down, if the path to the server is blocked, or if the file location information is wrong. It can also happen if the server has the service running, but the specific files referenced by the boot process are missing or incorrectly named. Exam questions may describe errors about not finding a boot file or failing to download an image, and those are strong hints that you are past the addressing step and into the retrieval step. That distinction helps you avoid choosing answers that focus on client addressing when the clue indicates addressing already succeeded. As with local boot, you are learning to place the failure in the chain and then match the answer to the stage. PXE can also fail in a way that looks like a normal kernel or early user space failure. And this is where beginners get confused, because the system might successfully download files and then still fail to boot. When that happens, the networking part did its job, but what was downloaded is not compatible with the client or is missing what it needs to proceed. This might be because the kernel does not have the right drivers for the hardware, or the early user space image is missing modules, or the configuration points to a root environment that cannot be reached. The symptom can look similar to a disk-based boot failure, such as dropping into an emergency environment or failing to mount a root file system, except now the root might be a network-provided environment rather than local storage. For exam reasoning, the trick is to notice whether the story mentions successful network boot steps, like getting an address and retrieving boot files, before the failure occurs. If those steps are clearly successful, the problem likely shifts from network reachability to the content and compatibility of what is being booted. This is a good example of how domains blend, because PXE ties boot concepts, networking, and hardware compatibility into one chain. A related point is that PXE often exists to start a temporary environment, not necessarily to boot into the final installed system, and that intent affects what success looks like. In many setups, PXE boots into an installer or a rescue environment that then pulls additional content, like packages or configuration, over the network. That means a boot can appear to succeed initially, but then later steps fail when the environment tries to reach additional network resources. On the exam, that can show up as a story where the machine starts a network boot environment, but then cannot continue installation or cannot access needed resources. The core reasoning skill is to identify which network dependency is being used at each stage, because early boot might require one service, while later installation might require different services and paths. This also explains why the exam might ask about symptoms rather than detailed configuration, because the goal is to see if you understand that PXE is a chain of network-supported steps. If you treat PXE as a single magic switch, you will miss that there are multiple points of failure with different symptoms. If you treat it as a staged process, the story becomes logical. Security and control are also part of the plain English understanding of PXE, because allowing machines to boot from the network is powerful and potentially risky. A network boot environment can install an operating system, run diagnostics, or access storage, so organizations usually control who can use PXE and what images are served. Even without diving into specific tools, you can understand that the network must be configured to allow only intended devices or intended segments to use boot services, and that boot images must be managed carefully. From an exam perspective, this often shows up as constraints in a scenario, like needing to ensure only approved machines can boot, or needing to prevent unauthorized boot environments from running. The important mindset is that PXE is part of the trust boundary because it influences what code runs before the operating system's normal protections are in place. That means failures might be intentional, such as a client being denied boot access. And your job is to recognize that security controls can look like technical failures from the client's perspective. Understanding that can change how you interpret a message that suggests boot is blocked rather than broken. Another exam-friendly way to think about PXE is to compare it to local boot and ask what changes and what stays the same. What stays the same is that you still need a kernel, you still need an early environment when the kernel needs help, and you still transition into a user space system that runs services and provides an interface. What changes is the source of the early boot pieces and the additional dependency on network readiness. Local boot is mostly dependent on local storage and local configuration, while PXE boot adds dependence on network identity, network reachability, and server availability. That means troubleshooting logic often starts with, did the client get a network identity, did it reach the server, and did it download the correct content? If you can answer those three questions from the scenario clues, you can narrow the problem quickly. This is exactly the kind of structured reasoning the exam rewards because it saves time and avoids random guessing. You are practicing the skill of mapping symptoms to stages. It is also worth highlighting that PXE boot can be sensitive to small environmental differences, such as being plugged into the wrong port, being on a network that does not carry the boot traffic, or being behind a device that blocks the necessary pre-boot communication. This sensitivity comes from the fact that the pre-boot environment is simpler than a full operating system, so it cannot adapt as flexibly. In a full OS, you might have robust drivers, retries, and tools to diagnose connectivity, but in pre-boot you often have only basic messages and a limited set of capabilities. That limited capability is a clue for exam questions, because the stories often include a failure that sounds blunt, like a timeout or an inability to locate a boot resource. When you see that kind of message early in the boot chain, think about the minimal environment and what it can and cannot do. It cannot browse the network like a full system, so it relies on specific information being available and correct. Small differences in the network environment can therefore have outsized effects on whether PXE works. When you put all of this together, the most useful takeaway is that PXE is a boot method that extends the boot chain across the network, and the chain is only as strong as its weakest link. The client must be able to identify itself on the network must allow it to reach the boot services, and the server must provide the correct boot program and images. If the chain breaks early, suspect addressing and reachability. If it breaks during download, suspect server availability or file location. If it breaks after download, suspect compatibility and the contents of the boot images. This staged thinking makes PXE feel less like a special topic and more like an application of the same boot reasoning you already know. It also explains why the exam includes it, because it forces you to connect boot flow with network fundamentals in a realistic way. You do not need to build a PXE environment to answer the exam's questions, but you do need to understand its intent and dependencies. Once you do, PXE stops being intimidating because it becomes just another story of handoffs, assumptions, and visible failure points. By the end of this lesson, you should be able to explain PXE as a pre-boot network-based way to obtain boot instructions and boot files, placing it correctly in the timeline before the kernel and early user space do their usual jobs. You should also be able to identify the three major dependency zones that can fail: getting a network identity, retrieving boot files, and successfully running the downloaded kernel and early environment. The exam will often describe a failure with just a few clues, and your job is to match those clues to the stage where the chain broke, rather than guessing randomly. If you keep the boot story in mind, PXE becomes a simple variation where the source of the early files is the network instead of a local disk. That understanding also prepares you for later topics where storage and networking intersect, because it trains you to think in terms of dependencies and trust boundaries. Most importantly, You now have a plain English explanation you can replay quickly under time pressure, which is exactly what you need when the exam throws a network boot scenario at you and expects a calm, structured answer.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.